Hello everyone, we are Team MonarchCredit and I'm Aryan Fanse. In this video, I'll walk you through our AI-powered event-driven credit scoring architecture built for Barclays. Our goal was to design a system that is scalable, explainable, compliant, and human-governed while still being production-ready for an enterprise bank. The journey begins when a customer applies for a loan through the Barclays Loan Portal. The customer submits KYC details, uploads required documents, and most importantly, provides explicit consent to access their banking data. This consent activates the RBI regulated account aggregator ecosystem. For example, entities like Finvu operate within this framework. An account aggregator securely fetches a customer's financial transaction data from multiple banks, known as financial information providers (FIPs), and transfer it to the financial information users (FIUs) like Barclays, strictly based on consent. So at this point, we receive two types of data: personal KYC data and financial transaction data. All this data is ingested into our event backbone powered by Apache Kafka. We use Kafka because it allows asynchronous microservice communication, enables multiple services to consume data simultaneously, and ensures scalability and fault tolerance. It also provides event level traceability, which is critical in banking systems. Once ingested, the data flows into a processing service. Here, we clean and normalize the inputs and deliberately remove the protected attributes such as gender, religion, or caste to prevent any kind of bias. This also adheres to the DPDP Act of RBI. The output of this stage is structured, fairness controlled, ML ready data. This structured data moves to the feature engineering service. Some features are extracted directly, while others are engineered, such as financial ratios or behavioral indicators, ensuring consistency with how the model was originally trained. These engineered features are then passed into the ML model, which outputs a risk score based between 0 and 1. A score closer to 1 indicates higher default risk. To ensure transparency, we use SHAP, Shapely Additive Explanations, which explains how much each feature contributed to the final risk score. This removes the black box nature of AI and makes the system regulator friendly and manager friendly. At the same time, the prediction is monitored by our model risk management (MRM) layer. And this service performs performance monitoring, drift detection, anomaly checks, and governance validation. If the model behaves abnormally or significant drift is detected, alerts are triggered. The risk score also flows into the decision engine. Here, customers are categorized into high, medium, or low risk segments. Based on this categorization, the system dynamically generates interest rates, collateral requirements, and loan eligibility parameters. This creates a risk-based pricing mechanism rather than a one-size-fits-all approach. All engineered features, risk score, and model versions are stored in our feature store. This allows periodic retraining, quarterly or yearly, so the model adapts to evolving market conditions. However, even after all AI processing, the final decision is made by a human manager. The manager sees the risk score, SHAP explanation, decision engine output, and the model risk management status. If the model is stable, the manager approves or rejects. If anomalies are detected, the manager can override the AI decision. This ensures AI assists decision making but does not replace human accountability. Once finalized, the decision is displayed to the customer along with loan terms such as interest rate and collateral requirements if approved. Before the process completes, every output from every service is written to an immutable audit trail storage. This includes ingestion logs, process data references, engineered features, model outputs, SHAP explanations, MRM monitoring results, manager decisions, and final customer outcomes. This audit store is append only and fully traceable, ensuring that any loan decision can be reconstructed end to end for regulatory review, dispute resolution, or internal audit. In an enterprise banking, this level of traceability is non-negotiable. Overall, our architecture is cloud native, microservices based, event driven using Kafka, explainable through SHAP, governed by model risk management, human supervised, and fully compliant with the account aggregator ecosystem. This ensures scalability, fairness, transparency, and enterprise grade robustness aligned with Barclays standards. Now, one of my teammates, Ruwan Shah, will take you through the uniqueness of our product.
So talking in terms of uniqueness, right? Most of the credit systems ask one question: do you have credit history? But we ask a different one: do you demonstrate financial behavior? This question alone helps us to evaluate millions of financially responsible individuals and businesses who are currently invisible. So most of the solutions build a generic model, they remove the gender ones, they optimize the AUC on Kaggle, and they stop there, right? But we did most of the three things differently. First, being a segment specific modeling. We've separated our features into businesses and individuals. Individuals including salaried individuals, gig workers, and self-employed. These are fundamentally different risk ecosystems. Mixing them dilutes signals, right? So we trained separate underwriting models with segment specific feature logic and importance ranking. Second important thing being feature fusion. So most of the team either use bureau data or they completely rely on alternative data. We fuse them both. For example, payment discipline is no longer just a credit history. It blends loans, utilities, rent payments, mobile payments, all into a behavioral signal. So practically same financial concept, but a stronger predictive power. So more inclusive. Talking about fairness, here it is not just a checkbox. Most of the teams might remove protected attributes once and might call it fair. But we built a proxy discriminator detector. So just after feature engineering, we compute dependency between every feature and the protected attributes. If any feature with strong statistical correlation is flagged and removed unless it has clear credit risk justification. Now this is logged into fairness audit file and rechecked after every retraining cycle. So fairness is continuously monitored but not assumed. Another part of this being ensemble intelligence. Instead of betting on one single particular model, we have bet on logistic regression for its transparencies, random forest for its obvious robustness, and XGBoost for its prediction. The weights shift by segments. So single model fails predictability, where ensembles covers all of these blind spots. Talking in terms of explainability, every borrower gets two explanations. A global explanation, that is their portfolio drivers. Second being local explanation on why your score changed. Our SHAP outputs are regulator ready and audit log compatible. So these are not just explainable, but deployable as well. So in the end, the thing that makes it unique is we didn't build a Kaggle model. We built a segment aware of fairness audited and an explainable credit intelligence architecture that fuses both traditional and alternative data and is ready for real deployment in an institutional environment like Barclays. So this isn't a model, this is a credit infrastructure layer.